So, how do we measure currents? These are the older methods where you had this little contraption that would drift along the currents. So it has these four vanes which will make sure that it's steered in the direction of the predominant current, east to west, north, south, or any random direction. So it's a floating device which is tracked through time to estimate the speed current at whatever meter per second, centimeter per second. Most of the ocean currents are of the order of centimeter per second, as we will see later on. The other one that's shown here with a propeller and a cage is a fixed current meter. So you would fix this contraption to something near the coast or somewhere in the middle of the ocean, and as the water flows through this propeller, the propeller converts the signal to a current, again in centimeter per second or some other unit. Okay, now more and more indirect methods are being used. Indirect means what? They are not directly measuring currents, they are measuring something that can allow us to derive the currents. What's the easiest thing you can think of? It's obviously the pressure gradient, right? If you know pressure difference between 2 points, then potentially that drives a current, and the pressure gradient can be related to the currents. Various other conditions have to be met in terms of frictional forces and so on. We will see that as we go along. And now there are satellites called radar altimeters. These are flying somewhere at 1400 kilometers above the Earth's surface, and they're measuring the surface elevation of the ocean at a few centimeters to a few millimeters. Okay, they're shooting down a laser and they're measuring the time it takes for the laser to hit the ocean surface and come back. So it measures ocean waves, ocean's motion, ocean's sea level rise, and so on. Has been an incredibly useful concept called radar altimeter, which is now used a lot for measuring sea level rise because of global warming, which we will see later on. Okay, so the other is the Doppler flow meter, terminology, but you can look up what it is. Again, it's an indirect measure of currents. Here is a image showing the ocean dynamic topography. This is what an ocean altimeter or radar altimeter measures, right? It's looking at travel time and telling you how the dynamic topography of the ocean is changing. Why is it called dynamic topography? Because imagine the ocean. We always say sea level pressure, and so on, but sea level is never perfectly flat. Even if the ocean was not moving, the surface will have high levels and low levels based on the gravitational pull on this rotating Earth, right? If you take a cup of water and you put a spoon and spin it, the water is not going to be flat, right? It's going to have this conical shape. Similarly, on Earth, you have mountains under the water which are pulling water down, and there are places where the water is not pulled down so much, or there is a big glacier sitting on Greenland which can increase gravity locally and pull some water towards itself, and so on. So essentially this surface of equal gravity can be thought of as dynamic topography, right? So what do we see here? We have already learned that the subtropical highs exist, and temperature of the ocean is not constant, and so on. So you can see these red areas with these circular currents in the Pacific Ocean, which is shown clearly, and a little bit of a circular motion here in the North and South Atlantic going in opposite directions, clockwise here, counterclockwise here, and so on. These correspond to pressure gradients. So if you have a high surface height, then the low surface height around it is going to create a flow down the hill. So that's essentially like a pressure gradient. We will see that later on. But these are indirect ways of deriving current. If a satellite gives you the ocean dynamic topography, then you can use that to derive ocean current. We won't get into the details, but we will just learn this quickly as a way that the ocean currents are estimated. Ocean currents are obviously very important for even helping ships and so on to navigate. Navies look for them all the time for search and rescue operations and so on and so forth. Okay, that's a very quick introduction to instrumentation, but we'll look at some more instrument in the next podcast.